Start recording again. All right, so good morning. Here we are solving equations again. Moving on to the next couple sections. Actually, I guess I apologize. I didn't realize there were some kinds of Martinich Math problems that really aren't covered in that section of the text, 2.2. They really show up in 2.3. And I got a couple questions from you guys. Hannah, I'm sorry, you could tell me again, is it Shauna? But I keep thinking of it incorrectly. But you asked a question. You asked a question online, and I actually kind of replied to the other type of question I was just referring to, rather than noticing exactly what your question was. I changed my answer this morning. I did think later I shouldn't even answer. I should wait and try to let you guys all chime in, which is kind of the point of the forum. But anyway, I hope didn't confuse you too much with that. But but for instance, I think the question that I saw from you, something like this, and it looked a little confusing for some reason. And this really is like problems that I tried to present yesterday. These are like terms. Somebody else, oh good. These are like terms, some X's and some more X's. Hello, Rachel, welcome. We have a new student joining us today. Anyway, these are like terms. We can combine those X's. +6 minus a 1, right? We don't usually see the 1. So this just means there's 5 X's that equal 25, whatever number might have been in your problem. And now we're trying to cancel out that 5. I would divide both sides by that 5. Too many 5s in that problem, but you know, that's what I end up with there for that kind of problem. So there were some problems where you had to simplify before we kind of get to that last step, multiply, divide, or add or subtract. And sometimes it's combining X's, and sometimes it's combining the constants, and sometimes it's combining both of those, boiling it down. All right. So that was really just trying a little catch up from yesterday. All right. Moving on then, if you're okay with that. 2.3 is, I think, is entitled Equations with Variables and Constants on Both Sides. Oh my. Well, this is really like, to start with, the kind of problem that I think it was Jeremiah sent me. Well, it's not just added, subtracted something. It's not just multiply or divide, it's some of both, right? My variable has a coefficient, or it's multiplied by 3, and then there's an extra 4 added to it. So I actually have to do both of those kinds of operations that we discussed yesterday, add or subtract and multiply or divide. Now, when it looks like this, like the variable simply multiplied or maybe divided like a fraction, plus or minus an extra term, the best technique is to cancel out that extra added or subtracted constant first. Move that one over, in a sense. And so the opposite of adding this 4 is subtracting that 4. We presented this sort of vertical format a little bit yesterday, right? So if I subtract that 4 from both sides, this side is left with the 3x. And here I've got -12 now. -8, -4 more, right? Now, oh, it looks like just the multiply or divide type. I'm going to divide both sides by the 3 and get a -4. Don't lose your negative sign. A -4 for that problem. So here's where we start. These problems might have a combination of multiply, divide, and add and subtract. So just going to do a few more of those, okay? And as always, slow me down if I start erasing too soon. I've got a few examples here with some nice numbers for me to use. I wonder if this works if I put it over there. Not really in your way, good. Same kind of situation. Whatever x stands for, I want 5 of them and 3 more. And then that expression, that total, whatever that is supposed to end up equaling -37. So I'm going to isolate or get the x's alone by subtracting this -3 from both sides. Whatever you do, you have to do to both sides. Just happens to be a negative number again, like the last example. So now to get 1x, I'm going to divide by 5 on both sides. So I get my -8. All right. Yeah. Very similar, but this time, after I've multiplied this variable, I've subtracted 9 from it. Again, let's get that variable term alone. I'm going to add 9 to both sides to sort of cancel out that 9. You know, I'm still kind of, as long as I keep it balanced, do the same thing to both sides. It's legal. Meet up one with a positive answer this time. And get 1x by dividing by that coefficient. Sure, why not? How about, you try that one? What would you do? Like, see if you can work that one out in 30 seconds yourself here. Let's see, I think, no, not even a fraction answer. Just to recognize I've got the variables multiplied by something, but something else subtracted also. So undo that subtraction, then get rid of the 3. So let's see, I think I get x equals 9. That work for you? Rattle, rattle. Just to fill in the blanks here. I add 8 to both sides, right? 3x equals 27, then divide by the 3, and I got an x equals a 9. Okay, so if it's not working, you know, jump in, say, wait a minute. All right, so here we start moving away from that type to ones where there's a little more of everything maybe on both sides. Well, look at this one. It doesn't just all equal a number, right? We've had variables on one side and maybe some extra numbers like we've just seen, some extra constants, and they're all supposed to add up or equal some final value. Well, this one's not in that shape, but we need to kind of get it in that shape. Our process basically here is going to be choose one side to get all the x's on and the other side to get all the constants on, and then we can do our add, subtract, multiply, or divide. So if I'm looking at this problem, it's like, well, I've got x's on both sides, so I need to somehow move some of those x's to the other side so that they're all together. Since this side has the constant already, and no constants over here, I'm going to leave the constant over there, and I'm going to move these 5 x's. I'm going to subtract these 5 x's from this side, which means I have to do it on the other side. You can do this just like you're doing it with the constant values. Add or subtract that quantity of x's. I'm not just subtracting a 5 or something, I'm subtracting 5 x's. I'm subtracting all those x's. And lining it up with these x's, I'm subtracting them over here also. Well, this will be nice, right? 6 of them minus 5 of them leaves me just 1. And those cancel each other, so x is a negative 10. Get your x's on one side, get your constants on the other. That's basically the procedure that we're working towards today with these kinds of problems, even as they get more and more complicated. Very similar. I've got x's on both sides and a constant also on that other side, just the number 10, an extra number 10. Notice these aren't like terms. I couldn't put them together. Somebody made an error like that on their test. So I'm going to leave that 10. I'm going to add 8 x's to both sides to remove those, in a sense, remove those x's from that side. So if I add 8 x's, got to do that on both sides. And negative 6 plus 8, I have 2 x's left. Those, on purpose, I did that to cancel them out, and 10 left here. So now I have this kind where, okay, I need to do a division. I have 2 x's, I want 1 x. So I'm going to divide both sides by the 2. Got down to an x equals 5. You can still plug that in if you want to verify, double check your answer. You know, you can always test these answers. Okay. Oh, just because. Last 2 examples, we had x's on both sides and a constant on the right. This is just the other way around. I've got x's on both sides, but the constants on the left. And so I'm going to choose to leave that constant there and move these x's again. So cancel them out by subtracting 3 of them from both sides. So that leaves a negative 14. These 2 x's. Dividing to get 1x, dividing by 2. There. X is on one side, use plus or minus, you know, to move that whole term in a sense. I refer to it, it's like, it almost looks like, oh, we took it from this side and we moved it to the other side. But it's, we moved its opposite, really. We moved it, its opposite to the other side. Not really, we did the same thing to both sides. That's kind of what it looks like when you're done. All right, let's jump up here to all right, next step up. Here I have variables on both sides and constants on both sides. You just need to choose which side do I want all the constants on and which side do I want all the variables on. And it doesn't matter, totally arbitrary. The signs kind of work themselves out. You'll always get the same answer to do it correctly. Just sort of preference. I kind of like to get positive x's. It doesn't really matter. So I'm looking at this and saying, oh, here's 6 of them and 12 of them. If I subtract these x's from both sides, 6 of them, I'll be left with 6x, positive 6x over here. But if I did it the other way, I'd get negative 6 over here. Doesn't matter. So it means I'm going to choose to move all my x's over here and all my constants, the numbers, whatever, the constants are over there. I'm just arbitrarily said, I'm going to go this, I'm going to go that way. So now it doesn't matter which one you do first. Like maybe I'd say, let's subtract these constants. Just be careful, don't do too many things at once. Didn't touch those x's yet, but that gets me negative 6. And now it's just like the ones we did a minute ago. Now I've got to move all the x's to the other side, so I'm going to subtract these 6 x's. Excuse me, 6 x's equals -6. Don't lose your negative sign. Don't you wish you could? I could just remind you in the middle of the test, right? Don't lose that negative. Blah, blah. And -1. Constants on one side, variables on the other. Go from there. Moving too fast? You'll jump in and stop me. I should put that on loop. I know I say it too often, but it's a good thing. Like this chilly weather, 41 degrees this morning. My first official long sleeve day. The polos are going in the closet. Anyway, here we go. Same thing. I've got constants on both sides and variables on both sides. Well, totally arbitrary. I think I'll move my x's to the left and move my constants to the right. All right. I'm going to move my x's, so subtract these 7 x's. Over here, that leaves me 2 x's plus a 4 equals a 12. Still a 12 out there, right? All right, got all the x's on one side. Let's move this 4. Subtract 4 from both sides. Let's cancel. Did that on purpose that way. And leaves me 8. I'll divide to get 1x. But x is a 4. Yeah, crooked. Same kind of problem. How about you get started? Can you make a choice? X is one side, constants on the other. Can you do those couple steps, moving things around? You might say, see what you get. Everybody's here, all right. Nobody's waiting, that's funny. Kind of doing it in my head here for a minute. You get x equals a 1, maybe, right? I think I'm going to move my x's this way. Now I got to move my constants the other side, add the 3. Divide to get a 1. And I got a 1. Silly. All right, hope that went okay. I don't think you're going to run into too many fraction problems in this section, but it could happen. Same. Oh, and let me make our life easier. Let's put a negative sign on that one, okay? -1/8. We get nice numbers eventually. Same situation. I need to get my x's together on one side and my constants together on the other. So I'm going to leave the 7/8 and I'm going to cancel out the -1/8. I'm going to add 1/8 x to both sides now. Just because the numbers are kind of nice, I can stack it up vertically, but you recall yesterday, sometimes if we're working fraction problems, it's really nicer to do that horizontal method, like writing everything in a line, because if you're gonna put those fractions together, and it takes more work. But 7/8 plus 1/8, I get 8/8. Can I just call it 1x? I don't know if I lost anybody there. And that canceled out. I skipped the 8/8 notation there. I wrote the 1, but usually we wouldn't even bother to put the 1 in there, right? It's always implied. I need to move the 12. So if I add 12 to both sides, I get my x equals 10. Okay. On to 2.4. It's really just a little more of the simplification situation that we've been dealing with our expressions in the last section. So how about usually helps if I read my examples and I get nice numbers. All right. Well, what's new here? Oh, I've got parentheses. I've got a grouping. It's got a variable in it. I can't really combine anything. I need to distribute. I need to use my distributive property to unlock what's inside the parentheses. So in 2.4, we're going to continue doing everything we've been doing, but sort of the first step is always simplify both sides as much as possible. Simplify both sides as much as possible. And then we'll go from there. Often we may end up with situations like we just covered with variables and constants on both sides. And then we start moving things around. So here, remember that means 5 times each of those. Positive 5 times x and positive 5 times 3. Unfortunately, I know I tried to emphasize it. Sometimes we're going to see negatives out there, and some of us still forgot to distribute the negative sign on our test. Oh well. So there, now I'm kind of like the last section, right? Got rid of the parentheses. I distributed. I'm going to leave all my x's here. That's all the x's I have. So I'm going to subtract the 15 on both sides. Let's get a 20 over there. And let's get 1x by dividing by 5. X equals a 4. This really is the extra twist that this section is adding right now. Yes.
I was just gonna ask if I did it twice. I did it both the way that you did it and dividing by 5 first on both sides, just because the other side didn't have anything else like to distribute.
Yes.
Is that going to work?
Was that Julia? I was just trying to figure out who was speaking.
Yeah.
Yeah. Okay.
Yeah.
You know, it would work. Yes. All right. It does work. You're kind of recognizing more things that are legal to do, right? This is just 5 times some number. And yeah, I can divide by that 5. And I guess I would have gotten what, a 7 first. Now, problem with that sometimes problem, not really, there's nothing wrong at all with doing that. But maybe you end up with a messier number, like a fraction sometimes. So you might just think ahead a little bit. Is that going to leave me a nice number to work with, or is it better to do it this way? You know, just
right. Okay.
Okay. Yeah. Good point. Good idea. Good recognition there. All right. All right. Simplify first and. Yeah. You can see that pretty well. Yeah, looks like it. All right, here's my expression. Happens to be in parentheses, and it's got a negative out in front of it. It really implies -1, right? If there's a 1 there, we almost never write it. But this really means, and just for emphasis, I'm going to put that 1 in there. -1 times each of those. Again, Julia, you could do what you just did, but that'll work. But this kind of works consistently, especially if they get more complicated in a minute. You'll see that you kind of have to be able to do this too. So -1 times both those values, -x -8. That's the place people make mistakes, is not putting the negative on the second term also. And -2. Now, I'm going to leave the x's over here because that's where they are, even though it's a negative. And I'm going to add 8 to both sides. I'll get -x is +6. I want positive x. You can think of that as having that 1 in there again. If I divide by that -1 to get positive, negative divided by negative, I'll get positive x equals my -6. Would work Julia's way too. Get my numbers closer here. Now, this is what I was referring to. Here's where, unless you're really comfortable knowing what you're doing, what Julia just suggested wouldn't work as well. Those last two examples, I could just divide by that outside number because it was those were the only terms over there, and kind of took care of it that way. This time, notice if I try to divide by 2, I could divide this by 2, and I could divide that by 2, but technically I have to divide the 3 by 2. I have to divide every term by 2, and that would make that a bit messier. So really, I do want to distribute and combine like terms and simplify first. All right, so 2 of this and 2 of that. My arrows all the time, right? And -8, and so here's the extra, +3 equals a -1. Unlock the stuff in the parentheses. And I just happen to have some like terms to combine here. We'll put those constants together. Now this is, remembering, I sometimes see folks try to do things like, oh, let's add them or something to both sides. See if I can think of that. But here I have -8 plus 3, -5. So that was all just still, didn't do anything to the right side. I'm just combining like terms, simplifying that side of the equation. Now I've got a multiplied variable and an extra added or subtracted term. I'm going to get rid of the -5. I'm going to add 5 to both sides and get 2 x's left, and that makes a 4 divided by 2, huh? Without really going too far down that road, again, it's an equation. As long as you do the same thing to every term on both sides of the equation, you're doing a legal thing that keeps the balance. I could divide this by 2 as long as I divide this term by 2 and divide this term by 2. I could divide them by 12 if I wanted to for some reason, but there's no good reason for us right now to do that. But as long as I do the same thing, I can add 10 and add 10. I just add a number as long as I'm doing the same thing, but we're trying to choose specific things that boil it down to what we want at the end. Just another one of those. Very similar. You can see what a mess it'd be if I tried to divide by 7 just to get rid of that fraction there, fraction there. You can do it, add and subtracting fractions. I know everybody really likes to do that. there was my distributing. 7 of those and 7 of those. 7 of those, 7 of those. Don't forget what else was there. Again, here are some like terms, some more constants to put together. The x's are still there, minus 29. All right. Maybe I'll get a fraction answer. I don't recognize this one. Leave the x's, they're all alone already, or all the x's are on one side. So I'm going to add this 29. Oh, yeah, nice number, 14, huh? Divide by the 2. Divide by the 7 to get a 2. Happens to be a 2. That's my answer. Hello, kitty. All right, step it up and good. We're doing good. Checking time there. Get my numbers right so it kind of works out nice. All right, this really is the same situation. It's just the piece that you'd have to distribute to wasn't the first piece. All right, here's a 12 standalone constant and a negative 3. We're subtracting 3 times this quantity. So really multiplying negative 3 times both of those pieces. Again, an unfortunate error. I tried to address it. You can't say 12 minus 3, oh, it's a 9. That's just the number 12. And this is 3 times all this other stuff. Well, that's going to turn into something completely different. It has nothing to do with this 12. So there's one of those things I kind of refer to it as a visual trap. Don't get caught there. So this 12 is still there. That gives me a negative 12 x's and minus 9. Didn't touch the right side yet. I still have some simplifying now to do on the left side. I have some constants I can combine. So how about 12 minus 9 will leave me a 3 minus 12x equals negative 17. And I'm going to leave all my x's there. I'm going to subtract this 3. Oh, look at this. We're going to get a fraction answer. Divide. If I have a negative, I want to divide by a negative. Negative divide by negative. Notice I'm just dividing by how many, the coefficient, not dividing by x's. That would like get rid of the x's. But that cancels there. Negative divided by negative is positive 20 over 12. And yes, reduce the lowest terms. I could cut it in half and get 10 over 6, and cut it in half again and get 5 over 3. Or notice I can divide them both by 4s and get 5 over 3. 5/3, a fraction answer. No reason it can't happen, although we do tend to present you with problems with integer answers. We sort of feel more confident about the answers like that when we get them. All right. So really, I'm just kind of building up the level of complication and the amount of simplifying required before we can do kind of our last couple steps. Yeah, squeeze it all in here. Get rid of this, okay? All right, it's got all that stuff on both sides. All right. So I have to distribute and combine like terms on both sides. And that means I'm probably going to have to move some x's around and some constants around to separate them. So here I go, 6 of each of those. 6x minus 18 minus 7. 5 of each of those. 5, oops. 5 times 4, 20x. Plus 15 minus 12. All right, simplify by combining like terms separately on both sides. Let's combine those variable constants. All right, Steve, slow down. Minus 25. 20x plus 3. 2. Both sides are now simplified as much as possible, but I have constants and variables on both sides. Pick one side to move all the x's to and another side to move all the constants to. Just because I'm going to move all these x's. It doesn't matter. You could go the other way. And I know I'm making a negative, but it'll work out. It'll be fine. So here I got what? Negative 14 x's minus 25 equals 3. Now I have to add 25 to both sides. Negative 14x equals 28. Just divide by negative 14. Doesn't cause any more trouble that it's a negative. And just don't lose that minus sign, right? Negative 2. Answer for that one. All right. My stand's casting a shadow. Oh well. It's kind of hard to get good lighting for these. Yeah, you're in some room of your house, right? I've got a little extra light shining over there. All right, talk about a couple weird things, weird ones, all right? What is that weird enough yet? Not too tricky looking. Maybe you could see, wait, that's going to be, what does that mean? Well, I just have to do some distributing over there. Not changing this. Do my distributing, 2 of each, I get 2x plus 6. Oh, 2x plus 6 equals 2x plus 6. Yes. What does it mean? Well, it means no matter what number I put in for x, it's always true. This will always be true. And I can play around with it and say, oh, well, what if I move all the x's? I get 6 equals 6. Yeah, that's always true. Or if I've moved all the 6's, I get 2x equals 2x. X equals x. Oh, it's always true. This kind, it doesn't depend. There is no one specific value of the variable that makes it true. It's true for any real number. Any real number. Any number on our number line. Fraction, decimal, pi, any number makes it true. This kind is referred to as an identity. Couple math words, right? Vocabulary, a little bit of vocabulary here, this last couple of concepts. It's referred to as an identity, true for any real number. I looked at the my open math homework. There's a couple where they ask you to choose the classification we're talking about. And one of them actually asks you to use this phrase if that's the appropriate phrase. Any real number works. All right. And in the interest of time, I'm going to do this next one that doesn't require too much work. This one says 3x plus 7 equals 3x minus 5. Well, when you think about that, how can that be? Well, let's say I try to move all these x's to one side. Right, subtract the 3 x's. I get 7 equals negative 5. right? That's not true. No matter what number I would try to put in for x, there's no way to ever make this one true. Notice the x's kind of go away and you get down to either that previous always true statement, 6 equals 6, or always false statement. Doesn't depend on any x's. No solution. And the special term, it's called a contradiction. There's a negative connotation to that term, right? Contradiction, that's the bad one. No solution, contradiction. Again, just we're classifying what kind of equations are these. These are the couple weird ones. Really want you to recognize and be able to apply a term to. Odd time, so I'll just say, now, so we're talking about these three, there are three classifications. I referred to previous example, identity, and that one was a contradiction. Well, those are the two weird ones, but what about all these other ones that do work and come up with a single answer? There is one condition that works. Those are all conditional equations, the normal ones. There's one condition that makes it true. Those are the two unusual ones, right? No solution or infinite number of solutions. Conditional. That's the one we work with mostly. Now, there's only a few questions that ask you to specifically classify the equations. Don't try to apply this to every problem that you're doing, right? If it asks you to classify it and choose one of these terms, then that's what you have to do. Okay. And I'm looking at my clock and say, we're out of time here, but we did get through all those concepts in this chapter, in this section. Again, I encourage you to, here we are Thursday, right? Look at 2.3 and 2.4. That homework, as always, is due Monday night, as well as I think it's 3 handed homework problems on a worksheet, getting you to practice these different solving techniques that we've covered in these 2 days. So not too much homework, I hope. Right. So good luck, give it a try, send me your questions as always, and I'll get back to you. All right, and otherwise, enjoy maybe a little rain this weekend. That would be nice for clear out the smoke and water the plants and stuff. All right, you guys take care, and I'll see you Monday, all right? Okay, bye.